Port of Livorno, Port of Hamburg, Qingdao Port. Nowadays, countries, especially countries who heavily depend on ports as part of their nation's revenue, are officially in the rat race. These countries have been directing all their attention on the development of 5G technology and its incorporation to port activity. Ports are an integral part of national economy and intermodal transportation. As the central gateway of Southeast Asia, Malaysia's ports provide excellent connectivity. This is because Malaysia lies in the heart of the region where intercontinental and intra-Asian trade routes meet. Meanwhile, China has long depended on its Southeast Asian counterparts, which consists of many developing countries such as Vietnam, Thailand, Indonesia, and Malaysia for export manufacturers. Just within the first half of this year alone, China's investment and construction contracts in Southeast Asia was nearly doubled to US 11 billion, as China proceeds with its ambitious plan to connect the country to other parts of Asia, the Middle East, Africa, and even Europe via its Belt and Road Initiative. Therefore, with rising container traffic, well-developed infrastructure, and a flourishing economy, Malaysia is also set to be one of the biggest beneficiaries of the Chinese giant's warpath. Speaking of ports and 5G technology, the world's very first fully automated 5G operated smart port, Qingdao Port in China, officially began its operations in 2017. Since then, Qingdao Port has been at the forefront of 5G implementations in the port environment and has reported a 70% decrease in labor costs and a 30% increase in overall port performance. The question being asked now is, what are the benefits of 5G technology in smart ports? How and why do we introduce it into our local ports? Now, let's retrace a little bit, shall we? What is 5G? Simply said, 5G is the next generation of mobile internet connectivity which will provide much faster data download and upload speeds, broader coverage, and enhanced stability. To the layman, it just means that they will be able to enjoy downloading a YouTube video in 1080p 4K in about a fraction of a minute. Sounds amazing! But to the experts, it opens up new possibilities such as the ability to support autonomous vehicle networks, remote device control, augmented reality, virtual reality, and even improvement in public infrastructure using enhanced sensors. Following the latest announcement of Budget 2020, Malaysia has declared its commitment to its participation in Industrial Revolution 4.0, allocating RM50 million to the development of 5G ecosystems. Major mobile service providers in the country, such as Digi, Celcom, and Maxis, have already begun the 5G trials since early this year, with more tests being planned next year. If Malaysia were to be able to successfully incorporate 5G technology into our local ports, it could exponentially improve the speed and efficiency of port activities, as Malaysia is currently set to draw in more container traffic following rising global trade tensions.
With all the hype surrounding 5G, the real question is, how will it revolutionize port operations? Well, to begin with, 5G networks are expected to involve logical network slicing. Network slicing is a technique of separating multiple virtual network partitions that operate on the same physical hardware. Each of these individual network partitions can be differentiated according to the quality of service requirements of the different slice tenants, allowing optimal allocation of resources, which in turn increases energy and cost efficiency. Compared to dedicated networks which require massive investment, 5G network slicing provides better use of network resources and greater operational flexibility, which makes it much more technologically attractive. Paired up with a reliable, resilient 5G network, it can also be used to improve traffic management in ports through an intelligent transport system, as traffic lights become interconnected and share traffic information through a dedicated network slice, replacing any need for underground cables. Services like this, which exist on each 5G network slice, are strictly time and location sensitive. Hence, these services require low latency and high reliability for the timely reception of messages, which so happens to be what 5G is based upon. Therefore, with 5G's boost in speed, stability, and capacity, 5G network slicing in port environments will be able to encompass an even broader scope of activity.
As the world storms towards a 5G future, 5G also accommodates the concept of placing the radio access network, or RAN, in the cloud to help cope with the sheer amount of data traffic in ports. In this Cloud RAN architecture, data flows for non-real-time functions are transmitted to each access point over the Mobile Cloud Engine, MCE, which prevents alternative transmission and reduces transmission investment by 15% and latency by 10 milliseconds. The Mobile Cloud Engine facilitates this by implementing complex management while coordinating multiple processing capabilities based on regional time, frequency bands, and space. Cloud RAN, or for short, CRAN architecture, allows operators to execute RAN functionalities together with other network functions, granting them the ability to offer new services over the network rapidly. But to truly get to know CRAN, we'll first have to look at its internal workings. In CRAN architecture, the physical layer is capable of detecting link failures and synchronization issues which are crucial in a shared network, as failure in one node could jeopardize the entire colony. The physical layer uses frequency division multiplexing channels, allowing large numbers of signals to be transmitted simultaneously, easing up traffic congestion. For the handling of events such as loss of synchronization, the Layer 1 in-band protocol sets up different control and management links to oversee them. Meanwhile, in the data link layer, high-level data link control (HDLC), which is a Layer 2 protocol, provides flow control and error correction based on retransmission in the case of packet loss. We have been talking about CRAN for a while now, but where does the CPRI-based in CPRI-based CRAN networks come in? CPRI, Common Public Radio Interface, is a specification which supports separation between the base frequency band and the radio frequency band. Through the deconstruction of a base station, a front-haul network will instead utilize CPRI protocols to carry digital signals. To reduce the possibility of any link delay, one method is to use bandwidth compression techniques. Bandwidth compression technique is a technique used to reduce the normal bandwidth of an information-carrying signal without reducing the information content. It is used to increase data transfer speed and reduce costs. When dealing with data transfer these days, Ethernet is the norm and the go-to. But the problem with Ethernet is that it is only best effort. And when dealing with CPRI-based CRAN networks, best effort is a big no-no. This is mostly due to the low latency and strict synchronization requirements of CPRI nature. Therefore, methods revolving around high-precision timing protocols such as Precision Time Protocol (PTP) over Ethernet, as use of synchronous Ethernet over multi-hop scenarios is mandatory, have also been suggested. Now that we know how important bandwidth is in a CPRI-based CRAN network to ensure smooth flow of data traffic, there has also been another bold idea to increase the bandwidth of such a network, and that is by using dark fiber. Dark fiber are unused fiber optic cables which are not connected to any phone company and depend solely on a company or individual to provide necessary components to make it functional. However, due to the nature of vendor proprietary specifications within the CPRI interface, this proposal can only come into fruition provided companies opt to use protocols which allow interoperability between non-Cisco devices, such as point-to-point protocol (PPP), which can also be used with both synchronous and asynchronous media. All in all, front-haul and CRAN technologies may not be a necessary requisite for 5G, but it is a crucial and economy of scale solution for 5G mass rollout, which will greatly support all port activities in Malaysia. The conversion process of a traditional port to a fully autonomous port is arduous and filled with challenges. The solution to this could be cloud vehicle to everything, an existing technology enhanced by 5G capabilities. With this technology, autonomous vehicles will be connected through a 5G cloud network, showcasing both peer-to-peer and client-to-server architecture. Through this network, various information is shared, enabling vehicles to communicate with surrounding infrastructure or even other vehicles in the supply chain, allowing them to make more well-informed decisions. This network architecture is also self-scalable, as new autonomous vehicles will immediately begin sharing information upon entry. With 5G's ultra-low latency, high bandwidth, and network reliability capabilities, Level 5 autonomy in vehicles may not just be a pipe dream. The system's incredibly high throughput and reduced latency speeds up the exchange of raw and processed data shared throughout the vehicle network, greatly reducing the chance for any major congestion. Frequency division multiplexing is also utilized for resource multiplexing across vehicles, as this will allow for a larger link budget, accommodating the large amount of traffic commonly seen in ports. Humans have made incredible achievements throughout history, and 5G will be the next milestone. But there is always a flip side to everything. While 5G will certainly lead mobile network connectivity to new heights, it is not without certain challenges and drawbacks. But even so, the many perks that 5G technology brings forward is one that we will all gladly embrace.